So the agenda for today is what and why of Azure Cosmos DB and its key capabilities. So I'm going to have a demo on Azure portal and demonstrating the demo there. React with Cosmos DB. So what is Cosmos DB is actually why we need this Cosmos DB nowadays. So today's applications are required to be highly responsive and always online to achieve low latency and high availability. In sense of these applications need to be deployed in data centers that are close to their users. Applications need to respond in real time to large changes in usage at peak hours, store ever increasing volumes of data, and make this data available to users in milliseconds. Azure Cosmos DB is Microsoft proprietary globally distributed multi-model database, as mentioned. Services are managing data at planet scale. The planet scale is the buzzword here. So mean for this is the data is available, accessing the data available geographically. That's the reason they're mentioning a planet scale is a word. It's launched in May 2017. It's 5 years ago. It's a schema-agnostic, horizontally scalable, and generally classified as a NoSQL database. Azure Cosmos DB is fully managed NoSQL database for modern application development, a single-digit millisecond response time, and automatic and instant scalability, guarantee speed at any scale. And business continuity is assured with SLA backend, availability, and enterprise-grade security. Azure Cosmos DB is a platform as a service passed from Microsoft Azure. It is not available as a no on-premises. Azure Cosmos DB is horizontally partitioned, so using replica sets to scale horizontally. It's also distributed globally. As I mentioned, it is geographically distributed across the planet. To make the data redundancy in built-in across any number of Azure regions. Regions are sets as data centers. Tier 1 Azure application this is. Add and remove regions from Cosmos DB through API programming. No application redeployment. It is managed by Azure. Highly available. Data where the users are available. Cosmos DB is multi-homing API. Requests are served from nearest data center. No configuration changes are required. Anything in Azure DB, Azure Cosmos DB. It's built for cloud. Cosmos only runs on Azure cloud. There is no on-premises version of this. So this is across global network of Microsoft data centers. The planet regions are available. Microsoft owns and operates one of the large backbone networks in the world. This global sophisticated architecture spanning more than 165,000 miles connects data centers and customers. The Microsoft Global Network is a central part of delivering a great cloud experience, connecting Microsoft data centers across 61 regions, 175 locations, and also it's have a 4,000 partner peers. The data can be replicated. So this is what the global network of Microsoft. The good part of the Cosmos DB is it supports multi-model database. This is a good point here. Every database will have either it's a relational database or it's a graph database or object database or document, key value or column wide. But here Cosmos DB supports a multi-model database. This is a good feature. None of the databases have these features. So a multi-model database in a database that can store, index and query data in more than one model. For some time, database have primarily supported only one model, such as relational database, document-oriented database, graph database, or column database. The database that contains many of these multi-model. So how the Cosmos DB is going to work here? So Cosmos DB have their own APIs. That API is going to work with your Azure SQL, native SQL, Azure Document DB, SQL, MongoDB to support MongoDB database, document database, Grammarly for graph APIs. Any future, any database comes, it is also supported by Azure Cosmos DB. It's guaranteed by Microsoft. So the traditional, we have RDBMS, we have it have asset properties like atomicity, consistency, isolation, and durability. The same properties here also follows for Azure Cosmos DB. And the thing is here, when we have previously in 20 years back, every database should have a first normal form, second normal form, third normal form. Due to the size of the data performance of the application, limited bandwidth. So these are restrictions are there in RDBMS previously. So coming to NoSQL, NoSQL, it's not SQL, but also no need to follow the rules of SQL actually. So we can have a redundancy data, duplicate data, we can put it, and no structured data, no schema-less. So this is all supported by the Cosmos DB NoSQL database. This also provides the APIs actually. Multiple APIs provided by Cosmos DB, that is MongoDB, Cassandra API, Gremlin API, and also we have support for the SDKs, Java SDK, .NET SDK, and the Cognito Search, the previous also. All this also have supported by this Cosmos DB. So single database, how it is supporting multi-model database is internally it's have mapping containers and items is internal mapping. So these are the physical objects of the Cosmos DB. So MongoDB, Gremlin, Cassandra, Azure are the wrappers on the containers. Containers are the database. Items are the tables, you can say logically. So containers for the MongoDB is collections. Items are the documents. The terminology is different for different database, but logically internally it follows containers and items by Cosmos DB. The Cosmos DB, the pricing purpose, they're going to calculate every request unit RU per second is calculated RUs, is called as the RUs actually. This RUs is provided by Microsoft for each operation what you do in Cosmos DB, a query or update and delete query, for any database or any MongoDB, Cassandra DB, whatever you do the transaction on the Cosmos DB, it's calculated on the RU. It may be one RU or it may be more than one RU depending on what you query the data. So this is called for pricing purpose. So how it is globally distributed Cosmos DB is it's the users related database. Wherever users are exist, the database data goes to that location, regional location, to perform very fast, quickly performance. So overall, this is the structure which is going to have a regions, data centers, and stamps, and domains, and clients, and machines. Machines will have a clusters and data replicas and Cosmos DB engine. So this is what every region will have. It follows this region topology. So your data will be replicated across the regions where the users are exist to get the data in milliseconds. The SLA is also mentioned by Microsoft. To achieve that, they are going to replicate the data in multi-region. So these are the partitions internally created by Azure Cosmos DB. As shown in the slide, the data within container is distributed along 2 dimensions within the region and across the regions worldwide. This is the Microsoft guaranteed hosting. Latency less than 10 milliseconds. High availability is 99.999%. Throughput, highly throughput, and consistency guaranteed. So this is what Microsoft Azure Cosmos DB is telling. The main concept of the Cosmos DB is the partition keys where the data is going to reside in the system. So partition keys are generated by an algorithm, and that partition key will be generated and that will be stored in a physical partition, and each partition will have a struts and those data, and it will be pushed to the data depending on your partition key. The partition key is a designated attribute within the document whose value is used to decide how to distribute the data. Cosmos DB uses hash of this value to ensure that every document with the same value of this attribute lands in the same place. Always we can call this distinct value of a partition key or a logical key. So Cosmos DB also supports the ORM DB support and Spring Data support and the data factory for Cosmos DB and data. And also Cosmos DB supports bulk data ingestion. Azure Cosmos DB have a good feature. There's a good feature called change feed. When any change happens in the feed of the Cosmos DB, we can trigger the event processing architecture. A stream processing architecture is available, and data movement with the feeds also available, supported by Azure. And also it's have multiple SDK support. Change feed processor is there. They are going to provide an API, so we can find out the change feed in the Azure Cosmos DB. And Azure functions, Lambda in AWS and Lambda, they can also support with DB triggers. We can trigger the functions whenever an event happens. Full model, I think in Khalid also mentioned the full model thing that was supported by this SDK. It's also supported for Apache Spark data analysis purpose. So Spark Apache also supported. How the security is providing by Azure Cosmos DB for the database? It's have authorization. You can have a key and value, and you can authorize. You can go and log into the application, and also you can mention users' permissions. So who can read, who can write, who can admin, who can delete it. So user set permissions. It's also supported by Active Directory. If you have any own Active Directories available, we can bring the Active Directory and we can integrate with Cosmos DB authentication. Network security is provided by own private network. We can be a virtual private cloud services also. We can add it, and we can give permissions to that, and only a VPN kind of can access through your Cosmos DB. Fail hours as per Azure Microsoft IP firewall is they have put a firewall for the network security. And any network failure any happen, it will automatically switch to the nearest region, and your data will be forwarded to there, and the data will be executed there. Even the network anything happens, the failures also happen. So global and local replications depending on your data thing, your data will be replicated locally or it can be globally depending on your pricing thing and your data availability. At least 3 data centers, the data will be available. Restoring deleted data by mistake, any region data deleted. So the auto replication happens from different region, and our data will be replicated automatically. The time they mentioned also 5 minutes actually. 5 minutes, within 5 minutes data will be replicated from the different regions. Backup automatically. It's periodical and incremental backups are available by Cosmos DB. So those will be automatically run the jobs and data will be backed up. Encryption address, data will be encrypted with your key, or you can bring your own key and data will be encrypted. Monitor and respond to the attacks. So network monitoring happens at Azure DB. Any network attacks happens, it will stop or it will inform the support team and they can take the action appropriately. Geofencing security also available. You can restrict the data, the regions which regions or countries where you can restrict the data. So that restriction can also happen. You can put a geofencing so that data will be available within the country as per the government regulations or regulatory authority. We can put the data there so it's not going out of the country. And also Cosmos DB also supported as notebooks. I think Pratyush mentioned in the data bridge session. So this is the Jupyter notebooks actually. So this is in preview mode currently supported by Cosmos DB. Using this, I think Pratyush mentioned Jupyter Python programming we can do for analysis, charts, analysis kind of thing. But Jupyter is written in Python actually, Jupyter. Yeah. And these are the business industries going to support using for this Cosmos, best using for the Cosmos DB application. Retail, e-commerce, manufacturing, logistics, financial services, and gaming. You can use this Cosmos DB is the best thing for that. So I will take you to the demo part and application Cosmos DB creation. Any questions? Just put the questions in the chat. I will once it is done, I will go back to the questions. So now I'm going to open Azure portal. Yeah, I opened Azure portal. If you want to go to Cosmos DB, you can search a Cosmos DB in the search bar in the Azure portal. You will find Azure Cosmos DB. So now I'm Cosmos DB. So these are the previously I created for testing purpose. So these are the database are available current. You can see here database names, the status is online or offline, a subscription model what we are using, and regions. You have seen here write region and read region. So whenever any write happens, it goes to the rest US. Read region we can give the our option to where the data can be written, where data can be read. So these are different regions are available here. So my data is writing here and my read regions are coming here. I can extend or I can increase or I can change these regions whenever I want it within a span of API. So now I will create a API. Let's see how the multi-model database is going to work. Let's create a database. As mentioned previously, it's the multi-model database. Whenever I start create database, it's asking me to which type of database you are creating, like a core SQL, native SQL, and a Cosmos DB for MongoDB, Cassandra, Azure native tables, and Grameen for graph APIs. So I can choose which one I wanted to have it here. So for just demo purpose, I will take a core SQL. A demo I will have with the Cosmos DB with the MongoDB, Cosmos DB with the MongoDB. With the React, I will have a demo later. Now just I will go to create a one small API. As mentioned, yeah, it's free trial and resource group is I will go with the existing one. This is my plan. Account name is my DB name actually. So which one I want to create it? Today I will create DB. So region location is asking, see, this is multi-region. So you can select the region where you want it. Asia Pacific, East Asia, or any other regions. These are the database available for the regions. I'll go with any stage. The throughput, processing throughput, what the queries you are accessing the throughput. This is the billing will be happen on throughput of this. And serverless, I think already mentioned one of the session serverless APIs also. It's also supported serverless also. Now I'll go with the provision throughput only. I mentioned as RUs, the billing cycle is calculated in RUs. 1000, I'm in the free tier, I'm going to get the 1000 RUs per second. So RUs including the CPU, memory, and my IOs. Three will be calculated and will calculate as a RU in terms of Azure. So this is 1000 that is giving by my free time. So I can also limit the total throughput. So I cannot increase my billing. Okay, we go with see global distribution. So how you wanted to distribute your database in global regions? Your redundancy as a free tier is not available, but multi-region. If you want to enable it in multi-region, so it will be across multi-region. It will data will be replicated. The data will be available. It will increase. Performance also will increase. Data getting the data. Availability zones. What are the availability zones you want to have it? So those only it will restricted. So I'm not going to use anything. Network security. Here I'm saying this is network security where I can restrict my Azure Cosmos DB who can access or from where I can access. So if it is private cloud or private company, or I can have my private cloud endpoint here. Now I'm going with all network, so I want to access this from public. So now that my database is accessible through public. So next option is backup policy. This is backup retention policies. How much data is going to have it? Periodic and continuous, both are available here. So backup interval and backup retention days. How many hours? Okay, how many hours or days? Whatever you want it. You can create the days here and interval. How many interval you want to back it up? And even the backup also, there is an option called geo redundant or local redundant. So you want to create locally backups or you want to create regional across the planet scale, you want to create any regions. So encryption, I said the database supporting the encryption keys. Service key managed by Azure, this internal system is generating a key and you can create the key. Or you can bring your own key and give the key name here, the key. So you can encrypt your data with your own key. So I'm going with the default key. The tags for just for building and purpose. So now I'm going to create it. Creation will take a few minutes. Why? Because you need to create across the regions and it can create and bring it up. Okay, it started actually. It take 5 minutes, so I don't want to wait for 5 minutes. I will go with the existing what I have created the tables. Let's say it will give one more pop-up once it is done actually. So let's go to home again. Let's see. Still it's creating. So once it is created, it will come here. Let's see. You can see this. You see here in the notifications, deployment in progress. The database is still in creating mode. So once it is done, it will say it is created done. So I will go with a similar one. So already created one SQL. This is my SQL type of multimodal database. It has the region available, read region, write region, and what is my to access this data, what is my URI, what is my option subscription ID, and capacity mode, provision throughput. So what are the tables? Containers means the tables and tables. Monitoring also available throughout here, so you can monitor the DB reads and writes here and any logs. If you have any cost accrued anything, the cost also will show here the cost. So this is the configuration of my DB. It also have other features. You can modify or change it. Replica, what you want, where you want to have replicas happen here. These are the available regions. So currently, I have not enabled my multi-region. It includes cost. So I'm using free tier. So I don't want to make it cost should be increased. So I have not enabled. If you enable it, ask where you want to enable it. Across regions. You can enable the data. Data consistency. Data consistency in a Cosmos DB is one of the challenging part. Whenever you write the data, when you're writing India region, it first starts India region, first it writes it, but it will take some time to replicate your write data whole regions, all the world planet. If you write goes to the India, read goes to US, then it might be the problem. Whatever you write the data, the read won't be happen. So there is a different consistency levels are available, 4 to 5 consistency levels are available. We can choose those. Now currently it is supported by session consistency level. So we have 1, 2, 3, 4, 5 consistency level we have. So these are supported by the Azure Cosmos DB. Strong consistency means the data will be written all everywhere. Then only the data is available to make sure the data is available. Until that, it waits. So your data may take few minutes, few seconds to get the data, read the data. Backup and restore. Whatever I mentioned, cost policy to access the data from other sites, dedicated gateway. You can have your own gateway to get the data access. We also have integration with other Azure services, Power BI service also available. Azure Cognitive Search, I think the whatever we have a previous session, so we can use Cognitive Search. The data can be ingested here. You can use for Cognitive Search. Add Azure function. We can add a triggers events, feeding events. We can add it here. And we can use. So integrations are also available for Power BI, Synapse Link, Cognitive Search, and Azure functions. Okay, we'll go to the important section called data exploring. So this is what we need to export the data now. Okay, I have tested data created. So now let's create it. If I want to create my database inside my data point, so create a container here. If you want, you can create a new container. This database, you can say, I will say some test DB. Here is asking you want auto scale or manual and share throughput. It's already asking by my max RUs, request units, how much you want. This is going to have 4,000. I don't want auto scale. Let's disable something. Yeah, 400 become. Even though it's costing 0.032 hourly by my RUs. Container ID means table ID here. Logically, container ID means table in our language. So I will say some table. Partition key is very important. What I mentioned. Data will be partitioned depending on your partition key actually. So something will need to put some category or ID. If nothing is available by default, your primary key is the partition key. If you have a location, Delhi, Bangalore like that, so you can put a location also. I'll go with some category. I'm going to have something to-do list. So this is my partition key. Analytical store on off is off disable. Advanced features also available. My partitioning key is larger than 101 minus no. So I'm going to create this DB and table. I'm going to create it. It will be available within 1 minute whenever you create database. If you see here, meantime, it's created. Notebooks is currently, it is in preview mode. Notebooks currently not available currently. It's not supported by Azure DB in this region. It created. Yeah. So I have created a DB, test1 DB. Now it's created. So test DB is created successfully. So this have a test table, means this item. Let's insert some data into this table. Let's insert the table. By default, my Cosmos DB supports JSON as a data. So let insert, and it also shows my primary key, sorry, my partition key here, and ID is primary key is followed by Cosmos DB. Let's insert some data here. So I'm going to add a new item here. So I will add a new item. By default, ID is mandatory, so ID will be populated here. I have test data is available. Let me take it. So my to-do list, this is. I put a category as my secondary key here. So same here. So I'm going to insert this data. I have inserted one row. ID is primary key, secondary, and some name, some description, some complete, some variable. So this is my, it's going to create like these are the columns. So save the data. Once you save the data, it creates a system properties automatically. We have created 4 fields, but it's created extra fields. RID is internal resource ID. This is going to be used by the table. Self ID, it is used for the concurrent access, cell ID. E-tag ID is for the versioning and versioning maintenance purpose. Attachment, if this have any attachments are available, and the attachments will be available here. TS is the timestamp. So when it's created the timestamp is the timestamp. So this metadata system process will be created for each row. So this record is inserted now. You can see ID is 1 and my category is my second. My partition key is personal. Let's create one more table, one more record. So 2, my category is business. Reminder, some message. Save it. Once saved it, again it got generated metadata custom properties. So now I have 2 records are inserted. Let's write some query. We can have a normal queries. We can write it. So by default, when you write it, C will be container. So select star from C. It gives your all data. So 2 records are available, 2 records we got it. See the query, the important part here, the query stats. Okay, now request, see for this querying my data, it took 2.2 RU request units. So you can see here actually. So it took 2.28 request units and it took 652 bytes and other information. The main thing, so the select query takes 2.28 RUs. Okay. We can also write, even though it's NoSQL, we can write where clauses also C dot category equal to personal. I have a personal one, deep one record is available. Let's see. It fetched one record where I have category equal to personal. And see the starts for this select query, again 2.82 RUs. So depending on data, is retrieving CPU, memory, and IOPS. So 3 will be calculated as the RUs. So this is a traditional database support actually. Okay. Now I'm going to go with I have developed a React with the MongoDB supported application. So now I took a MongoDB as a database data model. Let's go with that application. This is native SQL. Now let's run with my database, my DB. So I have written application React as the front end. The back end is Cosmos DB that's supported with the Mongo application, MongoDB database. So what I did it. So when I created a MongoDB, I will go with, it will take time to create. That's what happened to that old one. Yeah, it's created. Okay, it's created in station, it's created. Okay. I have created a MongoDB database. The type of database is MongoDB. See, you can see here in the Azure Cosmos DB API for MongoDB account. So I have created a MongoDB API. Whenever I open a MongoDB application, it gives the connection. I want to have a connection properties. So the thing is, I want connection string first. So this is MongoDB Cosmos DB with the MongoDB API supported. This is my host name is this. If you see the host name, I am demoed mongo.cosmosazure.com. So Cosmos DB with the Mongo supported API. This is a port. My username and my password is generated. If you want, I can copy this or I can regenerate also password. And also secondary password also available. Primary connection and also secondary connection also providing by MongoDB. So Cosmos DB. Even the first connection is down or something, so we can switch to second failover. The second connection is available. You can put in your application, so your application will always up and running. Through SSL, true, security is true. So this is what my connection strings. So what I will do, directly copy. You can copy the MongoDB connection string and put into the code. That's directly we can do it. Actually, everything is given by the connection URL is given by the Azure Cosmos DB. So we can copy and paste it directly into my connection. This is what I did. Copy pasted my application, the Cosmos connection into here. Right. What does this connection have is MongoDB, an environment DB name, a document Azure host name, a port, and SSL. This is what generally the format of my connection string. So I'm using Mongoose, but I'm using Node as a server. Node server I'm using for Mongoose as a module. Mongoose is my ORM tool for this. I'm using connecting Mongoose to connect to my MongoDB through Cosmos, this Azure Cosmos. So server environment. You see the environment. My key or the primary key is available. I can put it here and my DB name here. And I have written my own service. .gs. This is what my server is running on 3001 port. And MongoDB is my connection string. And my model is, this is my model. Model means entity object. What is my structure of the database? My table. So my connection is MongoDB. And ID is primary key, is the number, required mandatory is true, unique value, it should be unique value. Name as string, some saying I'm creating. So 3 fields are there in my application, ID, name, and saying, and auto index is false. By default, as Cosmos DB is auto index on every column. If you want to disable that one, we are up to the application programmer, we can disable it, or it is enabled by default. So I'm disabling it forcibly to reduce my cost. So this is my model object, and I have written a service layer to connect to my Cosmos DB. So these are my CRUD operations here: a get record, a create record, update record, and delete destroy record. I'm connecting my Cosmos DB. I'm creating a Cosmos connection here. Already created Cosmos MongoDB connection here. I'm going to connect here and reading the read preference is nearest. See the property here. So my read preference will be my nearest.
10 minutes left for your session.
Okay. Thanks. So nearest region, it will go and get the read record. So we need to provide the which preferences we wanted. So I have a get record, I have a create record, and I have update record, and I have delete record. So these are my APIs are written in Node. So this is a key functionality here. And also I have a front end written in my React.js. React.js only calls the REST APIs of the Mongo Node.js server and it serves the APIs. So let me start my server. Let me start my Node server first. So my server is server. Yes, let me starting the server. So I need to start my front end React application. Let me go for one more console. Start my front end application. So what happened here? So it's connected to the database and it's connected. And some warnings are given. Something is not going to support by next version of the MongoDB version. However, because we're using Mongoose as a ORM tool. So my application is up and running. My front end is loading now. And port number 300. It takes some time. Yeah. Build and run. So this is my front end application with React with Cosmos DB. I have a CRUD operations here. So I'm going to add a hero name here. Let's say one. Okay. Some GB and I'm going to say call it as a megastar. Okay. And I'm going to save the data here. I inserted one record here and let's see what happened there in my application. We go to Data Explorer, same thing in my application. Among my database and my heroes is my database here. Here you change the name here. You see here items and comes here documents. This is a multi-data model. It supports automatically the data. So I have insert recorded. Okay, this is my data table. Sorry. This is whatever inserted just now record. Here is came Chiranjeevi and Megastar. I am using a model object, so it's came ID, name, and saying. So this is my record, first record inserted. So let's insert one more record there. So I'll add one more record. So second record, some name. Save the data. I'm saving. So two records are inserted. So two records are inserted here. All can with PowerStar. So let's delete my application. So one record is deleted. So this is CRUD operation, create, get the list of these operations for the application. And one more nice feature here, you can integrate your Visual Studio Code with Azure functions. Whatever you are seeing in the functions here, the tables, you can get it here. The module, the library is available here. Extension.
Sudheer, we have 4 minutes left for the session.
So I'm done actually. We can access through Visual Source Code also. So this is all about Cosmos DB and retrieving data. So any questions?
Yes. I'll read the questions for you. So the first question is, what are the different levels of consistency available in Cosmos DB?
Yeah, as I mentioned in my previous, I think there is consistency levels. There are 5 types of consistency levels are available. Data consistency, default consistency, strong consistency, bounded stateless session, and consistency prefix and eventual consistency. So these are the consistency levels available supported by the Cosmos DB.
Yeah. So the second question is, what are the storage limits of Azure Cosmos DB?
Actually, there are no limits for the Cosmos DB storage level. It's unlimited as per the Azure Microsoft.
The next question is how to migrate SQL data to Azure Cosmos DB.
Yeah, it's up to what type of SQL it is. It is RDBMS data, or it is non-SQL data, or a type of MongoDB or Cassandra data. If you have that kind of aggregation of the data is available, we can migrate. There are tools available and also provided by Microsoft, also supported by migrating existing applications to the Azure Cosmos DB as they're providing these connections.
The next question is time to live supported for Cassandra tables?
Yeah, time to live is supported by Cosmos DB. You can mention if you want to delete the records for after 1 hour, after 1 day or 2 days or 7 days, you want to delete the records automatically by the system. You can put a TTL as a column name and you can mention what type of data, what expiry date for that. So it will be deleted after the TTL time.